Previously, we have solved logarithmic equations where they have the same base. So today we're going to learn how to solve if we have a log on one side but not on the other. So if we look at log base 5 of x equals 2, what we want to do is we want to give both sides a matching base. And so what we're going to do is we're going to match it up with our b value. And so that's why if you look, you can see we raise 5 to the log base 5 of x power and 5 to the second power. So when you do that, log 5 raised to the log base 5 of x, the log base 5 goes away, and so you're left with x equals 5 squared, or x equals 25. So that's one of the nice things about working with logs is when you raise it, when you put a new base in, the log is in the power, then it kind of cancels away. So if we go through some of these examples, so we see log base 2 of x minus 6 equals 5. So what I'm going to do is I'm going to raise both, put 2 as our base. So 2 log base 2 goes away. I'm left with x minus 6 equals 2 to the 5th, which is 32. And so I end up with x equals 38. And when I plug 38 back in, log base 2 of 38 minus 6 becomes log base 2 of 32, so that checks out. And that is equal to 5. The log base 2 of 32 is equal to 5. So if we look at number 2, we have log base 2 of x minus 4 equals 6. So the minus 4 is not in the parentheses, so we need to first add 4 to both sides. So now I have log base 2 of x equals 10. And I'm going to use a new base of 2 for both sides. So it goes away, and I have x equals 2 to the 10th power, which is 1024. So once we can get rid of the log, it makes it a lot simpler. Number 3 is similar to number 2. We have to get rid of this 1, so we subtract 1 from both sides. So I have log base 6 of 3x equals 2. And so I'm going to make a new base. So 6 raised to the log base 6 of 3x becomes just 3x equals 6 squared, which is 36, and it's easy then to solve for x. I get x equals 12. Number 3, log base 3 of 4x minus 1 equals 5. We got to add 1 to both sides. So we have log base 3 of 4x equals 6. And if you notice how I like to write it, I just kind of leave the previous line in, and my new base, I drop below it, and so everything else becomes the new exponent. The log base 3 of 4x is an exponent, and the 6 is an exponent. So now it becomes 4x equals 3 to the 6th. 3 to the 6th is 729. When I divide by 4, I'm just going to leave it as 729 divided by 4. That's the easiest way to do it. You can't really reduce it. Okay, now we have a number out front. We have like an a value, negative 4, times log base 8 of 3n equals 0. So if you remember, when we were simplifying, when we were condensing logs, we made that negative 4 the power. Well, we can still do our normal mathematical operations. We divide by negative 4, and so we have log base 8 of 3n equals 0. And so then I'm going to put my base of 8. I have 3n equals 8 to the 0, which is 1. So n equals 1/3. And then finally, I have another one just like it. I need to divide by negative 6 first. So I have log base 8 of 10n minus 8. And the minus 8 this time is inside the log. So I'm going to raise it to the 8th power, or put the base of 8. And so I get 10n minus 8 equals 8 to the third. 8 to the third is 512. 10n equals 520. N equals 52.